Triple students, welcome to the Waves and Electromagnetic Waves test walkthrough. Without a shade of a doubt, which three waves can cause ionization? Loads of you said gamma. Lots of you incorrectly went for microwaves. It's not microwaves. It's going to be ultraviolet and X-rays. You needed all three to get the mark. Okay, all three to get the mark there. Next question. Radio waves are used for television transmissions. Visible light's used for fiber optic communication, and gamma rays are used for medical instruments. You needed to get all three correct to get the 2 marks. Really important. Loads of you had issues with this particular question. They're asking for the wavelength. They wanted you to draw and label it with a W. So I would have done this little marker. From here to here is 1 wavelength. And from here to the midpoint is the amplitude. You needed both of them to get the mark. Okay, 1 mark for each one. Loads of you have got the amplitude, which is going all the way down to the bottom, which is incorrect. Loads of you got, wavelength spanning maybe multiple waves. Yeah, and both of that is, not right. So we want to get rid of that one. We want to make sure that this is only going halfway, okay, to the midline or the equilibrium point. The type of waves is definitely going to be a transverse wave, and the explanation is the oscillations are perpendicular to the direction of energy transfer. There is no other way you can get those marks. One for it being transverse, and the other mark for it being the correct explanation. No other ways you could have got that. Some people have confused the word oscillations and used the word waves. The waves are perpendicular to, no, it's not the waves that are perpendicular, it's the oscillations or the vibrations. But really, this is the gold standard I'm showing you. You should be using this in the real thing. Okay, the next question. The waves shown were produced in 2 seconds. Calculate the frequency of the waves. Well, you have to go back to the diagram. Let's clear some space here. And you have to look at how many waves you've actually got here. So from here, 1 whole wave to here, that's one wavelength. That's 2 wavelengths. Okay. Then we've got 3 wavelengths. Then we've got 4 wavelengths. Okay, so you've counted 1, 2, 3, 4 waves. So there's 4 waves. There's 4 waves in 2 seconds, which gives you an answer of 2. Okay, loads of you have got 2 divided by 1, which is shocking because you've looked at the diagram, you haven't seen the diagram, which clearly shows 1, 2, 3, 4 waves. Okay, that's not great. Calculate the time period of the waves. The time period then is going to be, well, how long it takes for 1. Yeah, how long it takes for 1. So if you know it takes 2 for 4, then effectively you're basically saying it's going to be, well, the answer is going to be a half unit is a second, but effectively you're just saying it's 2 over 4. Yeah, take 2 seconds to create 4 waves. So 2 divided by 4 gives you a half. Some of you are using halves in your final answer as a fraction, but really in physics we want to be using a decimal. You needed both of these to get that mark, both of them to get that mark. This is interesting, this question, because it didn't fit on your calculator, and I think there's a reason why that was done kind of deliberately. The key thing is to set up your formula box. So we asked for the speed of the wave, question mark, frequency, and wavelength. So the frequency, it says, is 10,000 million. 10,000 million. So I've got to think. So 10,000 million. So it's going to be 10,000. I need to add a million onto that. So it's 1, 2, 3, 4, 5, 6. That's the actual 10,000 million. Okay, that's pretty much what the question is saying. The wavelength here is 0.02. We know that. So literally, C equals F times by lambda. the speed therefore is going to be this 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 times by 0.02. This won't fit on your calculator, so you can't really use your calculator. So effectively, we know therefore the speed must have a 2 in front of it. We need to figure out how many zeros, and there's 8 zeros here. Okay, so it's 1, 2, 3, 4, 5, 6, 200,000. That's right. No, 200 million. 200 million. That's 1, 2, 3, 4, 5, 6, 7, 8 zeros. Yeah, like we said. How do you put it in standard form? Those of you didn't put it in standard form, you got to go now. So that's where the decimal point is right now. If that's where the decimal point is, sorry, forgive me. If that's where the decimal point is right now, it's right here, right at the edge. Then we basically need to move it in this direction. We need to count how many spaces. So it started here, 1, 2, 3, 4, 5, 6, 7, 8. You need to move 8 spaces. So my answer is going to be 2 times 10 to the 8. And it shouldn't be minus 8, it has to be positive 8. So 1 mark for the conversion. 1 mark for the correct answer in non-standard form, and the third mark for the actual answer in standard form. Some of you guys actually did manage to do this okay. It's not impossible, but it was interesting to see how many people struggled because you couldn't use your calculator. So yeah, okay, next one. When the microwave's working, it lights up the microwave. That's the microwave. Explain whether Simon was correct. Well, the simplest thing to say here is that the microwaves are not visible to the human eye. Okay, so that's the simplest answer for the first mark. Microwaves are not visible to the human eye, in which case he is incorrect. He is incorrect. And effectively we're saying that light is coming from the visible light. That's really important. You have to say the visible light is coming from a bulb within the microwave, is coming from a bulb. Okay, well, that's pretty much it. Yeah, you had to say that it was definitely had to use the word visible light. If you didn't use the word visible light, you're not describing a part of the electromagnetic spectrum. So microwaves are not visible to the human eye. 1 mark. And the fact that the visible light is coming from a bulb, or that the visible light is visible, is your second mark. Okay, next question. Lots of people did really well here. There's 2 ways you could have done this. I'm going to show you the easiest way. Well, you know that the pulse has had to travel all the way down and then bounce off, reflect off the sea floor and go back up. So the time they've got here, it says that the pulse returns 0.35 seconds later after leaving the submarine. That's the time it took to go all the way down and all the way back up. So the easiest thing is to sort this out by dividing by 2 first, which will give you 0.35 divided by 2, 0.175 seconds. And then we're using distance. So let's just write down the other. Distance is speed divided by time. Speed is distance divided by time. Distance is going to be speed times by time. So I could ask myself, what do I have in my formula books? Well, I've got a speed, 1,600 meters per second. That's there. Do I have a time? Yes, I do now. It's 0.175 seconds. And the distance is my question mark that I'm trying to figure out. Some of you divided this. You can't divide this. Okay, it has to be a timesing. So my distance is 1,600 times by 0.175. 1,600 times by 0.175, which gives you 280 meters. 280 meters. 1 mark for the unit. 1 mark for the answer. 1 mark for the correct substitution and dividing of the time. Okay. There's no way you could have done this. You could have just said the distance is 1,600 times by 0.35, which would give you 560. But 560 is going from the top down back up. That's 560 for the entire journey. So you just divide that by 2 and you get exactly the same answer. Okay, next question. Now, most of you didn't really look at how much you had to write here. It's a 3-mark question. It's a 3-mark question, so you ask yourself, well, I can't just say one thing, which is that the distance reduces, you had to do something a little bit more. Okay, and the important thing was to realize that pulse number 1 and pulse 2, the time stays the same. So we've got to describe what's going on within this part of the journey. Okay, then we want to talk about the fact that 3, the time definitely has reduced. Okay, then we want to talk about the fact that 4, the time has reduced even more, but 5 is the same as well. Okay, both this 0.25 and this 0.25 are the same. So, with regards to the journey, what's really important, we've got to say that pulse 1 and 2 show the distance stays or stayed the same, whatever distance it was. You didn't have to go and start calculating the distance. Some people did. Didn't give you any more marks, unfortunately. That is the first mark. Pulse 1 and 2 show the distance of the submarine to the floor stayed the same. However, in pulse 3 to 4, well, particularly in pulse 3, it's got the distance has got smaller. So why? Because the time's reduced. So pulse 3 shows the distance to the seafloor has reduced. Okay, because the time go down. So we didn't have to explain, it was just describing. Describe how the distance. I don't have to say explaining why because the time's gone down. I'm just describing what the data shows. Pulse 4 and 5 show the submarine got even closer, and that's the really important bit. You can't say it's the same depth. It's got even closer to the seafloor. The distance is reduced even more. Closer. So distance reduced even more to the seafloor. And pulse 5. So from pulse 4 to 5, it stays at that depth. And that was the final mark. Yeah, pulse 5 shows it stays at that depth. Okay, and that was the really important bit for the third mark. So those of you said, broadly, most of you in the entirety of what you've written only got 1 mark. Most people only got 1 mark because you say it shows the distance reduces. Okay, and it does overall from 1 to 5, but you were asked to kind of really what they're looking for in that 3 marks, we to do a bit more of an analysis. So pulse 1 and 2 show the distance stays the same. First mark. Second mark, the fact that 3 shows that the distance to the seafloor has reduced. Second mark. And then the third mark is 3 and 4, the distance reduced even more. And then 5, it stays at that same depth. That was your third mark there. Okay, so the ray diagram. Some people did well. I think the problem really is the fact that loads of you didn't draw the image. So I'm going to use my ruler on this diagram. Just bear with me. So I want to go from the top of the arrow through the center. Okay, I need to draw an arrow. Okay, it was a marks for drawing arrows on. Lots of people didn't actually draw arrows on, which was a bit annoying. The next one is to go straight, as we've done in lesson, in all those diagrams, straight across, straight across, so straight across from the top of the arrow to there, and then from the top of the arrow then through the focal point, and that was through the focal point was the really important bit. Some of you didn't go through the focal point. I've now got my image, which I'm producing here. This is my image, and I'm drawing that with an arrow. Now, it's not perfectly straight, so maybe I want to do that again. So I'm going to undo that, and I'm going to redraw it this time, maybe in different colours so you can see it clearly. I mean, the problem is that a lot of you guys use a pencil, fair enough, and it hasn't come out great on this, but straight down with the arrow being right at the point there. So 1 mark for 1 ray going from the top down. Second mark for the second ray. Third mark for arrows. And the fourth mark for image. which is drawn, right, starting at the x, so the horizontal axis of the diagram, the horizontal axis, and then finishing at the convergence points where those two meet. Those are the 4 marks there. To work out the magnification of the image, it's got to be, and some people didn't know the equation here, but it's going to be the image size, okay, divided by the object size. And if you actually use a centimeter ruler to measure those, then you would have found that it's around about 0.8 centimeters for your image, which is that one, okay, and the object is about 2 centimeters or thereabouts. I mean, if you were slightly off, I gave some people some marks, okay, and 0.8 divided by 2 gives you about 0.4 as your magnification. Obviously, magnification does not have units because the centimeters cancel out. So you had to measure that. You could have counted the boxes if you wanted to. That would have worked as well. But some people did nothing and just left that blank. It's a bit disappointing. Different wavelengths of light can be used to transmit information along the optical fibers. So read through the question. Lots of us found it difficult to actually do a comparison here. Lots of us spent a lot of the time describing, but actually didn't get any marks because you have to make a comparison. If you say, well, if you say at 4 times 10 to minus 7 meters, the 50 meter fiber had a certain percentage and the other one had a different percentage, and then in the middle it was here. And if all you're doing is describing points without saying which one's greater or which one's less, or making a comparison, you're not going to get any of the marks. Okay, so that was really, really important. So, the marks here, I'm going to do them in easiest first, I think, really. So the shorter 50 meter fiber transmits more light than the 100 meter cable and 100 meter fiber, and this is the really important, at all wavelengths. That's the first comparison, okay? That orange highlight is definitely always bigger than the purple one. It never crosses over. So that's the first comparison, easiest comparison. That's your first mark, pretty much. The second mark, for both fibers, the minimum percentage transmitted light occurs at 5, but it's not 5 on its own, it's 5 times 10 to the 7 meters. So you can just put 5 times 10 to the minus 7 meters. That is the second mark. The third mark then is pretty much saying that as the wavelength increases, the light decreases and then increases for both of them. So this idea that actually they start high, both of them start high, they both reduce, okay, to a minimum at 5, and then they both increase again. You're looking at that kind of relationship between the two, and it's quite obvious from the data that that's what it shows, but I think some people just thought it was too obvious and didn't write anything down. So increasing the wavelength decreases, then increases the percentage amount of light transmitted for both fibers. Yeah. So for both fibers, increasing the wavelength reduces, and I would say probably till 5 times 10 to the minus 7. Then increases the percentage of light transmitted. Okay, now that's pretty much what you needed to do. That's your third mark there. Now the problem is that some people did then kind of make a bit of a comparison about the beginning points. They said, it starts off, the 100 meters starts higher than the other one and the rest of it, but they weren't as high up on the list of priorities. Okay, so that is your final answer there. 1, the Shorter fiber transmit more light than 100 at all wavelengths. You had to use the word all. For both fibers, the minimum is at the same point. And the fact that the general trend is for both fibers that the percentage increases first. Sorry, the amount of, sorry. The both fibers, the percentage, the percentage of light increases first, then reduces. For both fibers, increasing the wavelength reduces, then increases percentage of the percentage light transmitted. Yeah, pretty much that's a third mark. Okay. Yes, this was a bit of an issue. Actually, when he said 100, a lot of people were trying to use 100 in the actual equation. So we're going to think about the formula box. C, what is F? What's the frequency? What's the wavelength? Well, we know the speed of light is 3 times 10 to the 8 because it tells us. Okay. And we're trying to calculate the frequency of light that is absorbed the most by the 100. Well, absorbed the most would be when it's lowest. So we're looking at this wavelength, okay, which is 5 times 10 to the minus 7. So 5 times 10 to the minus 7, C equals F times lambda. We're looking here at frequency, so we're going to do 3 times 10 to the 8 divided by 5 times 10 to the minus 7, which should give us, let's check this, divided by 5 times 10 to the minus 7, 6 times 10 to the 14, and that is the right answer, 6 times 10 to the 14. So you can't use 100 length, that's not a wavelength. Okay, and it's definitely not a frequency. So some people are trying to sit there trying to do 3 times 10 to the 8 divided by 100. Okay, that's definitely what you can't do. Okay, really important. The ripple tank question. Yeah. I mean, unless you had a really good stab at this, actually. I mean, I must say you didn't do shockingly badly. Very few of you left it blank completely, but a couple of issues. One, very few of you talked about the equipment you needed to actually do the measurement. They didn't want a method. It doesn't actually say in the question. It says, explain how a student could make appropriate measurements and use them to determine the speed of the waves. But it didn't actually ask you for a full method. And lots of you guys spent the entire first chunk of all these lines describing a particular method. Okay, and you didn't really have to do that. It was asked you about appropriate measurements to determine the speed. So the equipment really you had to mention was a ruler and you had to mention a stopwatch, and very few of you actually did that. Okay, and then there was a set piece with regards to working out the frequency and the wavelength. Okay, so the easiest thing is to structure it to the point where I want to talk about first how to work out the wavelength, then I want to tell them how to work out the frequency, then I want to tell them that it's the calculation. Now loads of you got the last mark, kind of this idea that you'd have to use frequency times wavelength to get the speed, but bits were missing from this for most people. Okay, so let's have a look at how we would start it off. Well, I would definitely say using a ruler. That's probably our most important thing. Using a ruler. Okay, we're going to measure across 8 wavelengths. Wavelengths on the white card. You don't really have to talk about turning the thing on and making sure the light's all there, because people, it's all in the diagram. There's no marks for describing the diagram, right? It's all here done for you. So it's not a question about what the method is. The method is pretty much given to you. Okay, you don't get any marks for describing what's going on here in the actual in the answer. So measure across 8 wavelengths on the white card. Okay, then divide by 8 to get the wavelength. Okay, and then if you need to, you can say convert to meters. Really important. So that's pretty much 2 things in one there. Now to talk about the frequency, using a stopwatch. So I mentioned the piece of kit I need. So using a stopwatch, measure how many waves pass a point in 10 seconds. Okay, then divide by 10 to get the frequency in hertz. Okay, at this point I might say repeat the above 3 times to get an average frequency and wavelength. Okay, and then using C or V equals C times lambda, multiply, I already kind of said that, but multiply the frequency by the wavelength, and really those are the average values to get the speed in meters per second. So that's literally pretty much it. Okay, that's literally it. So the equipment measured, I said use a ruler. I'd measure across 8 wavelengths. Then I've said I'd divide by it to get the wavelength. Good. I've said I use a stopwatch. I've measured how many waves pass a point in 10 seconds. Pass a point in 10 seconds. Then I've said I divided by 10 to get the frequency in hertz. Yes. Okay. Really, really important. So with regards to marks, you could, whoops. I wanted to get rid of the green one, but anyway. Whoops. So the first mark really, so if I just go back, the first mark is for saying a ruler and then saying you'd measure across 8. Then a mark for dividing by 8 to get the wavelength. A mark for saying using a stopwatch and passing a point in 10 seconds. A mark for then dividing by 10 to get the frequency. Then a mark for using the equation. And the final mark really, I think in some cases it's really good to give an average for all of them. That's really good. Okay, so 1, 2, 3, 4, 5, 6. That's pretty much the 6 marks. Okay, if you didn't mention the average, it's not fantastic. It would be best to mention the average, I think. Okay, next question. The wavefronts. Yeah, lots of us found this a bit tricky. Don't know why. Some people were drawing down here. Why are you drawing here? It says complete figure 4. This is figure 4, so whatever you've got to do, it's got to be somewhere within this region. Okay, so all you have to do is complete the diagram. The wavefront is, well, it's going to be moving fast in here, it's going to be slowing down here and speeding up again. Okay, so literally whatever it's doing on this side, it will be doing on this side. So you just have to have exactly the same gap. Now, I haven't measured it with a ruler. I should be measuring with a ruler, but it should look identical to this set over here. Whatever you're drawing on that side should be identical to this side. So some people had lines which are larger, which was no good, or lines which were closer together. They had to be exactly the same width as those guys. That's all you had to do. Literally it. Nice and simple. Oh god, this one. Yes, lots of people found this difficult. I'm not really sure why. Follow the rules. The first thing you do with anything is draw normal. So 1, 2, 3, 4. It's my normal. The normal had to go from the outside to the inside. It had to cross over, and if it didn't cross over, it wasn't great. So switch to blue so you can see clearly. We should be bending towards the normal. Some people bent all the way down the normal. That's not going to happen. Okay, so that was not right. You want to be going closer to the normal, and then what we've got here is a angle here, which is what you need, and the angle here is the angle of refraction. So you should label that as the angle of refraction. When the light leaves, you've got to draw normal to this surface. Well, the normal to this surface is going to be perpendicular to the surface. Perpendicular to that surface at that point. Well, the surface at that point, if I should draw the surface on, this is not something you have to do, but that's the actual surface. So a line perpendicular to the surface is there. So really what's happening is that the ray, so you didn't have to include those two at all. You just had to show the ray leaving, and the ray is going to leave without refracting because it's traveling along the normal. Okay, so the ray would have left because it's traveling along the normal when it's on that semicircular part. Okay, And again, when it comes to the semicircular part, if you've got a semicircular curve, you've got to figure out, well, where's the normal on this one? Well, the normal is going to be perpendicular to the surface. So if this is my surface, my point there, if that's my surface, then my normal really is 90 degrees to it. Which means if you're traveling in this direction, you will travel straight along the normal and leave. So there's no refraction. Lots of people were doing stuff which was going here and then moving in different directions. That's not going to happen because the ray at that point is traveling along the normal. So the marks, 1 for the normal, 1 for the angle, 1 for the line moving towards the normal, and 1 for it leaving without refracting. That's what the 4 marks were for. 1 for the normal, 1 for labeling the angle of refraction, 1 for the straight line going towards the normal, and 1 mark for it leaving. Why is light refracted? Just to paraphrase the mark scheme, there's a change in speed, it slows down, really important, and therefore there will be a change in direction. Okay, you can't say change of speed and then use the word it refracts. They gave you the word refracts, so you can't use that. 1 mark for change of speed slowing down, 1 for change in direction. That's what those 2 are for. 2 variables the student should control. The number 1 thing is the angle of incidence. Angle of incidence, that's the angle at which it hits the block. This angle here, that has to stay the same. Otherwise, it's just not fair. And really, you want to keep the nature of the glass block the same. So really, we want to talk about the type of glass, or some people said the density or the glass block. I mean, it's okay. Refractive index, unfortunately, is not on your spec anymore, so we can't use the word refractive index, but the type of glass block would have been enough to get you the second mark. So the angle of incidence is really important, and the type of glass block. Some people said the position of the glass block. That's not the top answer, NTTA. Some people's answers were not the top answers. These are the top answers. Why the results could not have been obtained using a normal protractor? There's a couple of things you had to mention here. One was the fact that the resolution of a normal protractor is smaller than these. The answers are in 2dp, so I would say the readings are in 2dp. A normal protractor does not have this high a resolution. Okay, so this high resolution, or this, we could just say this higher resolution, just put this here, yeah, so this higher resolution. So that's kind of your both marks, really. Normal, yeah, does not have them, so it could not measure. So it could not measure the difference between the results. Okay, that's really important. It would just come out as 27. You could only, well, I mean, if you rounded it up, you could say that all of these on a normal protractor would all come out as 28. You wouldn't be able to see the difference. Very few of you mentioned anything about the difference between the results, otherwise they would be the same. So 1 for mentioning the fact that it doesn't have a high resolution. A normal protractor doesn't have this high resolution. It only goes to the nearest degree, not the second decimal place. So that's what those 2 marks were for there. What conclusion can be made about the relationship between the wavelength of the light and the angle of refraction? Well, some of you struggled on this. You have to figure out what the wavelength is doing. Well, going upwards here, wavelength is increasing. Richard of Yoga is about to mention. So blue is small wavelength, okay, and red is large. That's AO1. You must learn that. And you can see as the wavelength is increasing, well, the angle is 7, 7, 8, 8, 2, 9, it's just definitely increasing. Some people said the word, it's proportional. It's not proportional or directly proportional. You can't use that word. You just have to say, because you don't know the start point. Directly proportional means, remember, it has to go through the origin. You don't know if it goes through the origin because you haven't got a value of 0 here. So you can't use those words directly proportional. So, again, paraphrasing the shorthand, so as the wavelength increases, the angle increases as well. Okay, and that would have been your mark. Simple as that. The longer the wavelength, the greater the angle. What happens to the ultraviolet when it's incident on the glass? If it doesn't transmit it, well, there's only two options. Either it absorbs the UV, or you could say it reflects the UV. Okay? So it's a combination of that. You got a mark for saying either one. Okay? So that's pretty much the rest of the test. That's all done. Yeah, so the major issues, again, going through is the refraction. This diagram was an issue. Make sure you got that right. The other issue was, lots of people got this particular one, the wavefront diagram, wrong. The 6 marker, a lot of you had a crack, but lots of you spent a lot of time mentioning the method, which there was no need to. They wanted the appropriate measurements. How would you make the measurements? What I've shown you here is the best. Some people mentioned phones and videos. It's fine. You wouldn't have lost marks for that, but if you didn't mention dividing by 8 or the time period or using the equipment like a ruler and stopwatch, you didn't get the marks. Lots of people got this wrong. This one was, a more difficult kind of AO3 question because it's analysing graphs. So don't expect you to get 100% on that, but that was a different one. This one should be nice and easy for everyone. 4 easy marks to gain. You just got to learn your ray diagrams, figure out how to do them. This was a bit more tricky for people. And this one was pretty well. This was the issue as well, which comes standard form. So keep an eye on that. Thanks very much for listening. I'll see you later. Goodbye.